Section 5.4 is factoring and solving polynomial equations. So you really should be familiar with factoring, so this won't be anything new, and you also know how to solve your factors. However, with polynomial equations, the factoring process gets a little more detailed. So I'm going to talk through each method that you're going to be covering. Before we start factoring, I want to remind you about prime factorization and what exactly it means. So if you note the first example here, it says this quadratic is not a prime polynomial in y. So remind yourself that prime means that it's all the GCFs are taken out, so you want to look for that greatest common factor, and then of course if it factors further, you want to make sure you do that. So for example, I can divide all of these by a 4. So I would pull out the 4, and that would leave me with 4x squared minus x plus 2. And again, I know you know how to do that, so just make sure that you do that. Then that quadratic doesn't factor down any further, so I know that that's prime, and that's what it means to be prime. You've taken everything you possibly can out, and you've checked that it's factorable. So here it says, a polynomial is factored completely if it is written as a monomial or the product of a monomial and one or more prime polynomials. So here's your monomial that you pulled out, and here's your prime polynomial that you can't do anything with. This one down here is not factored completely because x squared minus 5x minus 6 can be factored down to x minus 3 and x minus 2. So this quantity is really x plus 2 and then x minus 3 times x minus 2, and now that is prime. So remind yourself that you want to make sure everything is absolutely factored to the most that it can possibly be. All right, your first method, and note I have up here that you absolutely must know these. These formulas will not be given to you on the test. Now, how you use them, I'll go through in another video, but right now I would take the time to jot these down, so pause the video and make sure you write these down. They're also in your textbook, but you're going to be factoring the sum of two perfect cubes or the difference of two perfect cubes, and I have an example of each down here. So this would be the sum, obviously because it says plus, and it's two perfect cubes because x is x times x times x, so that's a perfect cube, and 8 is 2 times 2 times 2, which is 2 cubed. The other one I have here is obviously the difference between two perfect cubes, and 27, again, is 3 times 3 times 3, so that would be 3x quantity cubed, and 125 is 5 times 5 times 5, which is also a perfect cube. So if you get that, and that's not challenging to understand, then all you're really going to have to do is identify what the two perfect cubes are, and that would be x and 2, and then you're going to be replacing those x's and 2's into this memorized equation. So it's pretty easy as long as you know this and you don't make an accidentally come up with the wrong number that creates the perfect cube of 8. Same thing here, what two numbers are cubed? A 3x and a 5, so I'm going to be putting in 3x's and 5's here. And again, I'll walk through that in a different video. The other method is called factoring by grouping, which actually might be familiar to some of you depending on how you learned how to factor initially. But just some key things when you factor by grouping, you should have 4 or more terms. Typically in Algebra 2 we're going to stick with 4 terms, but it could be 6 terms, it could be 8 terms. It's usually an even amount of terms, although it doesn't have to be. I promise you really though, in this class, in this term specifically, we're going to stick with just 4 terms. So if you want to just jot down that factoring by grouping right now is just going to be 4 terms, I think that's fine. And then grouping, of course, means literally you're going to group things. So typically you just group the first 2 together and the last 2 together, and then you go by taking out stuff that you can. Because notice I wouldn't be able to divide all 4 of these terms by anything. But the first 2 terms I can take out an x, and that would leave me with x minus 2. And the last 2 terms I can take out a negative 9 or a positive 9, but I'm going to take out a negative 9, which will leave me with x minus 2. Okay, so again, I took out an x because that was common. I took out a -9 because that was common. And notice now that these factors are identical. If they are not identical, then you are going to be stuck. Okay, the point of factoring by grouping is to take enough stuff out of each group to come up with a commonality. Okay, and now I want to just sidebar here real quickly. If you have 2x times a plus 4 times a, you can take an a out of everything. So you would do that. You would take an a out, and that would leave you with 2x plus, I probably don't want to do a 4, because I can also take out a 2, and that's not the point of my problem, so I'll make that a 3. And anyway, you would take out an a. Well, here, you could take out an x minus 2 from everything. Okay, so if I factor out an x minus 2, that's going to leave me with x minus 9. And that's sometimes hard for people to see because you get it when it's like taking out a monomial from everything, but when you're taking out a binomial, it's just a little awkward initially. Some of you might get that, some of you might not. If you don't see it, understand that your common factor, you write down once, and the stuff left over becomes your other factor. All right, then your last factoring technique, so you're going to have 3 of them, is factoring polynomials that are in quadratic form, and these should look familiar. So I'm going to just make a note here. What if I changed this one to 4x squared minus 9? I hope at this point you would gather that that's going to be 3x, not 3. I hope you gather that I just made a mistake. That's going to be 2x plus 3 and 2x minus 3. Like that should be absolutely no problem at this point in your factoring career. So now look at this one. It says 4x to the 4th minus 9. So the only difference is I have a 4th power instead of a square. So if you think about when you take x times x, you get x squared. Well, what times what is x to the 4th? X squared times x squared. So good news for you is that's going to factor down to 2x squared plus 3 and 2x squared minus 3. This is just a sidebar. And so, you know, very similar. And that's why it's called factoring polynomials in quadratic form, because it's going to be exactly like factoring quadratics, but it's going to be bigger degrees now. Okay, so same thing down here. If I thought this were an x squared and an x, I would know how to factor it. So I'm going to factor it like a quadratic. So I'm going to do the FIFO method for those of you that prefer. If I take 6 times 5, I get 30. And what are factors of 30 that add up to -7? And that would be -12 and 5. So then I'm going to write 6x, but now instead of just x, I have to do 6x squared because it's x to the 4th. And then minus 12 and 6x squared plus 5. And then I can take out a 6 on this one. So that's going to leave me with x squared minus 2 and 6x squared plus 5. And there are my factors. So it's very much like factoring a quadratic. It's just going to be higher degrees. So remind yourself about that. All right, lastly, you're going to be solving these polynomials. So the factoring process after you factor it, then you're just going to be solving those. So I am not going to focus on the factoring part of it because you're going to watch other videos, but I'm going to factor this one down real quickly. So this is the difference of 2 perfect cubes, 2x cubed and 5 cubed. So once you have these formulas down, and I know you don't yet, you would understand that this is going to be 2x minus 5, and then it's going to be 4x squared plus 10x plus, whoops, 25. Okay, and that all equals 0. So then how do you solve? And you should know this. You take each individual factor and you set them equal to 0 and you solve. So the first one is very easy. You would add 5 and divide by 2, so you get 5 halves. And then this one, of course, is a quadratic. So you're going to have to use, the quadratic formula, or it's not factorable, but you could certainly try if you don't believe me. So quadratic formula, completing the square, etc., etc. I'm not going to go through that because that should all be reviewed from last chapter. Okay, in part B, of course, this was actually the problem I factored previously, but you'd get 5 over to the other side, and then you would factor that down. to 6x squared and x squared, and then this would be, sorry, I made a mistake there. So factors of 6x to the fourth are 3 and 2x squared, and then it's going to be minus 5 and plus 1. So you would get 6x to the fourth, yep, so that works out. And of course, again, you're solving these factors, and now it's quadratic factors, and I'll just go through one of them. So you would add 5 and divide by 3, and then you would square root both sides, right? So you're going to get plus or minus the square root of 5/3, and you would rationalize that denominator. So it's actually going to be the square root of 15 over 3, and that's going to be 2 of your solutions. And then you would do the same with this one, but I won't do that because you'll be watching more videos on this. So the solving process gets really lengthy because you have to factor, then you have to solve, and the solving gets lengthier.